Now let's look at more examples. This question says evaluate these questions. Now it says what happens to this function as x tends to infinity. In this case, x tends to infinity. Now let's look at our int. Our int says the first thing to do is to check the numerator. Numerator is the up value of a fraction, and the denominator, which is the down value of a fraction, for the highest power of x, and we divide through by the highest power of x. So if we check the numerator here, we see that the highest value of x is x raised to the power of 2, meaning we have to divide everything here by x raised to the power of 2, which we did here. So it will be 3x squared divided by 2 plus 2x divided by x squared plus 4 divided by x squared plus 2x divided by plus 4x plus 4 divided by x squared. So in this case, x squared will cancel x squared, x. So what remains here? 1x, right? This one nothing cancels here. 1x cancels 1x, 1x remains here, and this one nothing. So what we have here is that we have 3. Okay, yeah, remember there's x beneath it. So in this case, this gives us 3 plus 2. Okay, I've written it here. This gives us 3 plus 2 over x, because there's 1x remaining here. This doesn't cancel, so we just bring back our 4 over x squared. This one, 1x remains down, so we have 2 over x plus here we have 4 over x squared. So now in this case, we can now put our value of x, which is infinity. So if we put infinity here, we have 3 plus 2 over infinity plus 4 over infinity plus 2 over infinity divided by 2 over infinity plus 4 over infinity. Now what happens here? What happens is that we have 3 plus, now recall we said x divided by 0 will give us infinity, right? So the x divided by 0 gives infinity. Is that also good? So we can say this divided by 1, we can say x equals to, that's x times 1x, then we say 0 times infinity, right? So if we divide both sides by infinity, infinity cancels infinity here. We also divide this by infinity, so we see that we have x divided by infinity. It will give us infinity cancel infinity, so what remains here is 0. So we can see that x divided by infinity will give us 0. So let's go back to our calculation. Now our calculation says 2 divided by infinity, like we just saw. 2 divided by infinity will give us 0, and 4 divided by infinity will also give us 0. Then the denominator, 2 divided by infinity will give us 0, 4 divided by infinity will also give us 0. So we can see we are getting the value of 3 divided by 0. 3 divided by 0 will give us infinity. So what happens to this function as x tends to infinity is that the value gives infinity. The value is in infinity. Is that okay? Good. Let's solve the second question. Now the second question tells us to find what happens to this function as x tends to infinity also. We do the same thing here. We find the highest value of x, the highest power of x rather. So in this case also x squared, so we divide through by x squared. So we have 6x divided by x squared minus 4 over x squared, then 3x squared, and so on and so forth. So x squared cancels x squared here. In this case, 1x cancels 1x here, remaining 1x. 1x cancels 1x, remaining 1x. Same thing here, remaining 1x. Now bringing it down, we have 6 divided by x minus 4 over x squared, and so on and so forth. Here 4 over x plus 1 over x minus 3 over x squared. We put our value, which is infinity, into this. So we have 6 over infinity minus 4 over infinity squared. And all of these, like we saw in our last example, will give us 0. This will also give us 0, divided by 3 plus 4 divided by infinity will give us 0, 1 divided by infinity will give us 0, and 3 divided by infinity will also give us 0. In this case, we are having 0 divided by 3, and 0 divided by 3, as we know, will give us a value of 0. In the next video, we are going to be looking at the shortcuts to solving all examples relating to our function tending to infinity. Once we have a function in which the variable x tends to infinity, there is a shortcut for solving or to solving that example. So in our next video, we will be looking at that. Thank you for watching. Please don't forget to like, comment and subscribe to the channel below. Thank you.